In this video, we'll talk about interfaces. Now, before we start with interface, let's talk about the abstract class. Now let's say I create an abstract class here. So we'll say abstract class A, and in this class, let me create some methods. Now we all know in the abstract class, we can create our abstract methods and normal methods as well. But let's say if I have abstract class which only has, let's say, abstract methods. If I say public abstract void show, and we have public abstract void config. Now when you have abstract class with two abstract methods, of course this works. There is no compulsion to have non-abstract methods here, or we call them as concrete methods. There is no need for them. Now whenever you have a situation where you have an abstract class which only has abstract methods, we have another way of doing it. Now see, all these are decided at design time. So when you make an application at designing, you specify things, okay? What are the classes I need and what are the abstract class we need? So you create this hierarchy of system. Of course, we'll talk about that hierarchy in some time. Why do we need it? But at this point, we create a hierarchy. And when you have a class which only has abstract methods, the other alternative for that is to create an interface. So instead of creating an abstract class, we can create an interface. Most of the time we use this interface in project development. So let's understand that. So we have the interface A. Now you will say what is changing there. Now first of all, interface is not a class. Okay, so that's the main difference between abstract class and interface. And by default, every method in the interface is public abstract. So these two keywords are actually not required because anyway they are public abstract. So even if you don't mention, they are by default public abstract. And that's why if you can see, when I put a semicolon just after the method, there is no error because behind the scene, public abstract is there. Now this is your interface. So interface basically means it's like a class, just that all the methods are by default public abstract. Okay, but then how will I use this? How will I instantiate this? The same problem was there with abstract class, right? We cannot instantiate it. Now if you look at this, how do I instantiate? Let's try. So I will say A, obj. See, there's no problem in creating a reference of it. So that also means we are creating a type. The way you create classes. So let's say if A is a class, you can say A obj. So A is a type, right? In the same way, here the interface A is a type. Okay, this works. But the moment you try to create object for this, it will give you an error. It says, if you see the error, it says cannot instantiate the type A because it's an interface. You can't instantiate it. Okay, what's the solution? The solution is, see, first of all, why do we get interface? We get interface so that we can design something. We can say, example, let's say if you ask me about how do we create a table, I can say, or maybe if you ask me how to reach somewhere. So I can say, go straight, take a right, go straight, take a right, take an auto, take a bus, get down at the next stop. So what I'm doing is I'm giving you the path, right? I'm giving you design. You have to literally take a walk. I will not walk for you. I will just show the directions. In the same way, interface says, I will tell you what are the methods you need, but I will not implement them. It is your job to implement. So when I say your now, I'm talking about classes. See, ultimately, you create object of a class. Interface just show you the design. So here what I can do is I can create a class. Let's say class B. So we have a class B here. And then in this class, I want to implement these two methods. Now in terms of abstract class, we say extends, right? Because class extends another class. Here, A is the interface. We have to use a different keyword here. The keyword which we use is implements. So whenever you want to implement the interface, you say implements keyword. And when you say implements, it becomes compulsory for you to define both the methods. Okay? If you fail to define both the methods, by default, your class also becomes abstract. Okay, but we don't want to create abstract class, right? We want to create a concrete class. We want to create object of B. In that case, it's your job to define both the methods. Okay, there's one way you can use a shortcut here. You can just go back here and say quick fix. It will ask you to implement the methods. Or you can do the hard work. You can say public void show. And then you can define something here. I can say I'm defining in show. And then we can define another method as well, which is config or public void config. And here we can define in config. So basically what you're doing is you are implementing both the methods. As I mentioned before, if you fail to implement these methods or this class becomes an abstract class, but we are implementing it, right? Now when you implement, basically you can't create object of A, but you can create object of B, and you can see it works. And now using this obj, I can call show, I can call what other method we have? We have config. So we can call both the methods, and that perfectly works. If I compile and run this code, you can see it says in show, in config. Okay, what else? Can I have, so the way you create variables here, also the way you create methods here, can I create variables? Now, first of all, we don't define variables, right? We declare them. So we can actually. So if I say int, let's say age, that's a variable. I don't know why I'm taking this age variable every time, but let's say we have int age here, and let's say we have string area. So that's the area name. But you can see we got an error. That means I cannot create variables? That's weird. I just said we can, right? So the only thing is, every variable in the interface, we can create actually those variables. The only thing is, they are by default final and static. So all the variables inside the interface are by default final and static. Okay, so that means we have to first initialize the variable. So when you say it's final, we have to initialize the variable, right? Okay, that's not my age, but let's say 44, and let's say area is Mumbai. Okay, so basically what we're defining is we are defining the age, which is 44, and the area is Mumbai. Now these variables are final and static. Now first of all, since they are static, which means we can directly use the interface name. Remember, when we use static variable, we don't have to use the object. Example, if I want to print the value of name or area here, I can simply say A is the interface, A dot area. I can directly use it, not with the object. And if I compile and run, it works. You can see we got Mumbai. If I try to change the value of this, if I say A dot area is equal to, let's say if I want to change the area to Hyderabad, it's not working. You can say it says the final field, that's right, the area is final. It is static, we are using directly the interface name, and it's also final. Okay, so that's one thing you have to remember. Now you might be thinking why it has to be static final. See, first of all, you don't instantiate the interface, right? Whatever you instantiate is a class, and you're not doing extents, you're doing implements. What you get in implements is only the methods, right? You don't get the variables there in implements. So that's why it is static, because we want to use the interface name, and final because interface objects or interface don't have their own memory in the heap, right? What you create object of is of B, not of A. So if you don't have your own memory, how can you have a non-final variable? So this is interface. Now in the next video, let's try to understand why do we need interface and why do we even need abstract class. Okay, let's talk about those things in the next video. In fact, before talking about the need for interface, we have one more thing to add here. So let's say if I have an interface and I'm creating a class which implements one interface here, can a class implement multiple interface? Example, let's say if I have interface which is called X, so if I say interface X, so B class implements A and X both, and the answer is yes. If you can see, there is no error here. The only thing is whatever method you define here, so let's say the method name here is run, you can see we got an error here. The only thing you have to do is you have to define run as well. So you will say public void run. So basically we can have one class implementing multiple interfaces. Now that's not the case with abstract class, right? Because in abstract class we can extend only one class. In interface you can have a class implementing multiple interfaces. So here I can simply print running. Okay. So what we are doing is we are using multiple methods here. We have 3 methods coming from 2 different interfaces. This interface says 2 methods, show and config. And this interface has only 1 method, which is run. And you can see we got 3 methods here. There's one more thing. Let's say we have one more interface, which is called interface Y. Now the thing is, when you talk about class and class, a class can extend another class, right? What about interface? Can we do interface and interface? What keyword we have to use here? See, whenever you have interface to interface, we say extends. So interface Y extends X. So inheritance is valid here as well. Now in this Y interface, you will be having a method called run. So that's the inheritance. Okay, so you will get this declaration in the interface Y as well. Let me show you. if I remove this X and if I keep Y, even now we have to use run. Otherwise, if you remove run from here, if you comment this part, you can see it will give you error. It says the type B must implement the inherited abstract method run. Okay, but we are implementing Y, right? It's just that Y extends X, so we have to use run. Now, point to remember here is whenever you have a class to class, we say they extends. Whenever you have class to interface, basically a class is implementing interface, so we have to say implements. And whenever you have interface to interface, we say that extends again. Okay, this is the point you have to remember. So again, I will uncomment this part. Okay, now there's only one thing you have to remember. Whenever you create a reference of A interface and object of B, which is a class, I can only call two methods, which is of part A. If I try to call run with A, it will not work because A has no idea what run method is. If you can see, in A we don't have run. In fact, what I will do is I will just remove this code for time being. Yeah. And then if you want to implement run, if you want to call run, in that case, we need to create the reference of X, which is obj1 is equal to new B. Now with this obj1 I can call run, but again I can't call two other methods. Okay, so that's one thing you have to remember. Okay, now once we are good with this, let's try to understand what's the need of the interface. Let's try to understand what is a need for the interface. Now for that, let's take an example here. So let's say we have a class here. And so the example which I'm trying to take here is for the developers. Let's say when you join a company, of course, as a developer, when you join a company, you want to write code, right? You want to build application. And if you have seen the trend, whenever you join a company, most of the company will give you a laptop to work on. And luckily, if you get a MacBook, that's great. So they give you a laptop, right? So that's the thing, right? If you want to work in a company, let's say if you go to an office and if you want to work there, you will say, hey, I want a laptop. So in this case, let's say you are a developer. Okay, so I will say you are a dev, right? Of course, you're a human, but let's say you're a developer. And then as a developer, what you do, you make applications, right? Or maybe I can say you write code. I will say dev app. You develop applications, right? Now, when you say you are developing an application, of course, you will say coding. Okay, you're building an application here. Of course, as a company, if I want to build a product, I have to hire developers. Now, in this case, let's say if I hire a developer, let's say developer name is Naveen, and then if you say new developer, and with this object Naveen, I can say Naveen.dev_app, right? So I want Naveen to develop application. And if I compile this code and if I run, it perfectly works, right? Now let's say, if I say, hey, I will make an application, but I need a laptop first. I cannot work without laptop, but we don't have laptop, right? So what I will do is I will create a laptop class. I will say class laptop. And in this class laptop, of course, in a laptop, what you do is you write code and I can say coding, right? In fact, what laptop, when you say code, it basically you code, then you compile, then you run. So you do all those stuff, right? So I'm saying code, compile, and run. And now, as a developer, what I want is if you ask me to write a code, what I will do is I will just say, hey, give me a laptop. So basically, you have to accept a laptop object here. That's right. You can also pass the object. So this developer will say, give me a laptop, and then I will write code. So here, instead of saying this, you can simply say lap.code, right? Now, since you have a laptop object, you can basically call this method called code, and it will work. So what I'm doing is, I got two classes here. One is developer, and second is laptop. And inside laptop class, I have a method which is code. And then once I pass this object, I can simply code, right? Now the only thing is when you ask a developer to write a code, developer will say, hey, give me a laptop. So that means first you have to create an object of laptop. So I will say laptop lap is equal to new laptop. So we got a laptop object. Of course, every developer needs a different laptop object. So let's say if you hire 5 developers, you need 5 laptops to give them. Okay, I will say lap here. Now this should work. There's no problem. If you can see the code, everything should look good. If I run, you can see it still works. So basically we are saying code, compile, run. So what you're doing is from the main method, you're calling dev app, which is here. and then you're passing the laptop object. Okay, so you're passing this object here. And when you accept this object, you're calling the code method. So it will call this code method and you have to execute this part. Everything works well, right? Now the only thing is, do you really need a laptop? See, in some companies, they give you a desktop, right? So if you go to the office, they will have a desktop where you have a monitor, you have a desktop, a good desktop which works. So why, as a developer, you are asking for a laptop? What if company wants to give you a desktop? You can't say, hey, I cannot work without laptop, right? You should be able to work on any computer. So let's say you also get an option of desktop there. In fact, in desktop as well, I can do the same thing, but I will say faster. Right? Desktops are always faster than laptop, right? So you can see when you're coding, it says code, compile, run faster because it works fast. Now, what if a company says, hey, we don't have laptops with us, but what we have is we have desktop. I will say desk is equal to new desktop, and they don't want to pass the laptop object. So when the company says, hey Naveen, you have to work, you have to make an application, and what we are giving you is not laptop, we are giving you a desktop. Now Naveen will say, I can't work. You can see Naveen says, I can't develop application because my application only needs laptop. You can't do that. So writing laptop here is an issue. We can't do that, right? So how do we solve this problem? And that's what, when I was talking about abstract class and interface, I told you about the design thing, right? So when you make an application, you have to make it more flexible. Here, what you're doing is, you're doing a tight coupling here, which is, you are saying that developer is dependent on a laptop. No, developer is not dependent on a laptop. Developer is dependent on a computer. A computer can be anything. A computer can be a laptop. A computer can be a desktop. So if you want to improve this example, what you can do is, you can create a class called computer. Okay. And in this computer class, you can say public void code. And basically, I want to keep this empty because I don't want to write a code because computer does not exist, right? It's just a concept. And I can say a laptop is actually a computer. So when you do that, the advantage is, in fact, desktop is also a computer. So when you do that, what happens is, now both this laptop and desktop, they are computer. So when I'm creating a reference of it, so can I say computer lap is equal to new laptop and computer desk is equal to new desktop? We can do that, right? We can create a reference of a parent class, an object of a subclass, and that's what we are doing here. Same thing can be applicable here, right? As a developer, you are focused more on the computer, not on laptop or desktop. The moment you do that, you can say everything is working. There's no problem here. It's because what you are passing here is desk, right? Which is desktop basically. But that is referred as a computer. And what you are referring here is a computer. There's no mismatch here. You are passing a computer reference. You are accepting a computer reference. But when you call code, it will be called based on what object you are passing. So basically we are passing desktop object. So when you say code, it will call the code of the desktop, not of the laptop. Let me show you. So if I compile this code and run, you can see it says faster, that's desktop. But now if I pass a laptop, let's say company decided to send you a laptop, and now when you compile and run, you can see it says code, compile and run. There's no faster here. That means that's laptop code. So that's how you design the application, right? To make it loosely coupled, where your developer object is not dependent on a laptop or desktop, or it is dependent on a computer. Any computer will do. A mobile phone also do because that's a computer. Now there's one change. See, if you look at this code, we're doing nothing, right? So instead of defining it here, can I simply declare this? And we know when you're declaring it, we can make it abstract. And since your method is abstract, you can also make your class abstract and problem solved. And that's the importance of abstract class, right? You can create that abstraction layer where you say, we are not working with laptop and desktop. In real world as well, we do that, right? Sometimes we don't mention rose or lilies or sunflower. We simply say flowers, right? We don't say apartment or a villa or anything. We say house, right? So we try to generalize things in real life, in virtual world as well. It's good to generalize things instead of specializing things. There's one more. Don't you think we can also use interface here instead of using abstract class? So we are using interface. We don't need public abstract. The only change you have to make is instead of using extends, we have to say implements. And that's the beauty of interfaces. right? Uh, I know we have written a lot of code. Maybe you have to watch this video once again to understand and try it by yourself. That's when you will understand the power of the interfaces. And what you are creating here is not the classes reference, we are creating interface reference. Yeah, and that's the importance of the interface. In this video, let's talk about enums. Now, enums are named constants which we create. So basically, if you try to have some constant example, when you talk about error codes, or if you have worked on a networking concept, so let's say when you send a request to the server will give you some status, right? If it is accepted the request, if it is rejected the request, or the resource not found, the forward not forward error. So basically, we have these numbers for every type of data you get from the server. And also we can have a name for it. Now, when you know that we have a specific error codes, or when you have a specific constants which you want to use, instead of creating a different object by yourself, you can create an enum. Now, how it looks like, let me just give you a simple example. So let's say we have enum here, and I'm saying I want to go with enum of status. So I will say status. Now in this status, I can have different constants which I want to use. Now of course you can create a class and you can create multiple objects of it. So let's say this status can be of running state, of failed state, success, pending. So you can have all those things. And of course you can create a simple class called status and you can create multiple objects, right? But just to keep it simple, we can use enum where we can define all the names constant, and this is pre-built, okay? Example, let's say if you talk about status, I can have status like running status. I can have status, and of course you can separate them with the help of comma. You can say running, then we can have failed, then we can have pending, and let's say success. Of course you can change the sequence, doesn't matter, but you can have this constant. Now the advantage for this is, if you want to use an application where you want to return a status to the client, that status can be running, the status can be failed, pending, or success. Instead of returning a string format or a specific object, you can simply return this status. Now how easy it can be? It's very easy. You can just go back to your main method and you can say, I want to have a status. So you can create a status reference, which is S, let's say. And this is same as what you use normal variables. Example, if you want to say int I, and then you assign the value as well, right? Let's say 5. So we have this int as a type, then we have this I as a variable, and then we have a value which is 5. In the same way, you can have a type as status. That's right. This is a type of it. So all these are objects. Now this is something different in Java. Now if you're coming from C++, in C++ we directly create the status and we have all these constants. And it treats enum in a different way. But Java says, oh, everything is class here. So basically the status is a class here. I know that sounds weird, but yeah, that's how it is implemented. This is a class and all these are actually objects of status. So by default, you got 4 objects. And you can use any of the object here. Example, I want to use, let's say, status dot running. Now that is my object which is assigned to S. Now, of course, you can print this S here and it will print the running status. So I can say compile and run. You can say it says running. So basically you can use any status here. Now, what are this? Just to reiterate, these are actually named constants. So instead of using numbers or string, we can use named constants. It will make your work a bit easy. Again, I'm not saying you have to use this everywhere, but if you have a scenario where you want to use constants, we can use this concept. And you can use any constant here. We are using running. I can also use failed, even that works. Compile and run, you can see we got a failed status. But yes, if you try to use a status, let's say no idea status, now if you can see, this status don't have any no idea, and that's why you can see we got an error here. It says no idea cannot be resolved or is invalid field. That's right. So you can only use those status which you mentioned here. Now in other languages we have one more thing, all this actually has a number. So basically you get numbering for it, maybe 1, 2, 3, 4, so that you can pick the status based on numbers. In Java it starts with 0. So this is 0, 1, 2, 3. And if you want to get that, you can actually do it. So once you get a status, you can use a method called ordinal. So different constants here have different numbers. This is based on the numbers, right? The order of it. So this is first, second, third, fourth, right? But when you have 0, 1, 2, 3. So when I try to get the ordinal of running, of course it will print 0, and that's what you want to see. So you can see we got 0. But yes, if you change it to success, which is 3 in this case, you can see we got 3. In fact, you can also print all. What if you don't want to print 1? You want to print all here. So what you can do is, instead of getting one status, you can get all the status first of all. Because if you say status.success, it will only give you one status. But what if you want to get all? So in that case, instead of saying this, you can say status dot. So there's a method here. If you can see, we got values, and that's right. Why we got methods is because the status is a class, and you get some inbuilt methods. Now, from where you're getting these methods, we'll talk about it in some time, or maybe in next video. But you got methods. So you can see status.values will give you what? Okay, so let me just jump to values just to see what it will give you. So status.value will give you an array. You can see it gives you an array. So on this side, we have to say this is not a normal variable. This is a array. And for that, maybe I can say SS just to have a different name. And once you got this array, you can print all. How? You can just come back here. You can print all. Let's try. I'm not sure if you can get all here. No compile time issue. Run, or it is printing the address or something. Ignore that. Okay, so what you can do is you can specify the index value. I can say 0. It will print running. Yeah, it works. But then what if you want to print all? And we have seen it, right? We can use a for loop here. Now, which one? I will use enhanced for loop. So I will just cut this part. I will use enhanced for loop here. And every time you iterate, of course, it will give you status, right? So what is this array? This array is of type status. So it will give you one status at a time. So you can say status s colon ss, and here you can print the status. So basically it will print all the status for you. So you can see it is printing all the status. Now with this s, you can also print the order of it just to see how it works. So you can say s dot ordinal. It will print, yeah. So it will also print the order of it, 0, 1, 2, 3. Yeah, so this is the basics of enum. We'll do something more about this in the upcoming videos. So let's expand our example of enum with if else and switch. Now, as I mentioned before, these are constants, right? So basically when you have this constant, can we just compare them? We can actually. The way you compare normal variables or strings. So let's take an example here. Let me just remove int variable there, and let me also remove the array. Let's keep it simple now. So let's say I have a status here, and s is equal to, and the status which I want to set is, let's say, pending. Okay, initially the state will be pending, and this value can be coming from anywhere. Maybe you called a method which returns this success or this status, and you want to check what is a status, and based on that you want to print some value. Example, if it says running, I can print all good. If it is failed, I can say try again. If it is pending, I can say please wait. If it is success, I can say done. So how do I know what is this value? For that we have to compare, right? So you can say if the s is equal to status dot running. If this is a status, I will come back here and I will print all good. And I can say if else, I want to check for the second one. I will say if status dot if it is matching with failed, I can print try again. Else if the status is equal to, s is equal to status dot, let's say pending. Now in this case, I can say please wait. Else, of course, you can also do if else if here, but we only are left with only one status. So I can say else, I can print done. Okay, so basically you can actually compare the status with the help of if else, and we can just come back here, say compile and run. You can see it works. It says please wait because the status is pending. But what if you got a status which is running state? In that case, it will print all good. Okay, so this is how basically you can work with if else. But what if you want to work with switch? Because see, in switch there is a limitation which a switch can support, right? It supports integer, string, and many more. But here the question is, does it support enum? And the answer is yes. So what I will do here is, instead of using if else, I will just reuse the code, but I will use a switch here. And in this switch, you can pass the status as it is. There's a change compared to if else, which is when you say case, in if else you basically have to use the status as well. But in case you don't have to do that because anyway the S is of type status, right? So it knows whatever you're passing is basically part of a status. So you can directly use the constant itself. So I can say running. If it is running, I can just print this statement. And of course in switch we have to also put a break. And then we can check for the second case. So that's case failed. And here we can have try again. So of course you have to say break here as well. What else? We have two more. In fact, let me just delete the entire stuff from here, if part. I'm so lazy, I can just reuse this. So the next status is what? Pending. In pending, I can say, please wait. And then the last one is success. In fact, for success, instead of even writing the case, we can say default. And here we have to give a colon and we have to say done. So basically whatever we have done with if else, we can also do it with switch. And switch actually makes much more sense here because we are working with constants, right? So switch looks good in the case of enums. And now the question is, will this work? Let's try, compile and run. It works. You can see it says all good. But yeah, if I change the status to, let's say, success, I just want to see if it prints done. Yeah, we got done. So this also works with switch. So that's how we can use if else and switch with enum. If you remember, we have talked about enum and I have also mentioned that enum is a class, right? So does that mean we can extend any other class? The thing is no, that's a thing which is not suitable here. You can't extend enum with any other class. Apart from this, everything is same. That means you can define methods, you can define constructors. That's right. You can create constructors, you can also create your own variables inside the enum. And that's what we are going to do here. Okay, so what I will do now is, and there's one more thing. If you remember, with enum, we have used certain methods. For example, if I come back here and if I say status was the object S. Okay, here, let's do it here. So if I say S dot, you can see we'll get some methods here. And we all know that by default, every class in Java extends object, and that's why you will get the hash code and then toString methods, which is here. But what about these methods? Ordinal, name, and then compared to. Now from where you are getting all these methods? So by default, enum in Java extends a enum class. Okay, let me just prove that to you. I will just print it here, s dot get class dot get. So what I'm doing is I'm getting the class name and the superclass of it. So I'm just trying to print the superclass of our class enum, and I will just compile and run. You can see it is enum. So enum in Java extends the enum class, and all these extra methods you get it from enum class. Okay. Now once we are good with this, let's treat our own class as enum, and I will do a different example here. Instead of using status, let's try to use laptop because we have to use some constructor and stuff, which makes much more sense with the laptop. And let's say we have some laptop models which I love. Example MacBook. Then we have Dell XPS. Then we got Surface. Not a big fan of Surface, but let's say Surface. The Microsoft laptops, and we have ThinkPad. I used to love ThinkPad when it was with IBM, but anyway. Okay, so we got these constants here, right? And then what we can do is, let's say for every laptop, I want to define the price as well. Now, how can we do that? So what we can do here is just after this MacBook, because that's an object, right? So just after this, I can say, hey, MacBook will cost you, let's say $2,000. XPS will cost you around, let's say, $2,200. XPS are a bit costly. And Surface is, let's say, $1,500. I'm not sure the cost. And let's say ThinkPad is $1,800. So we got this cost for these laptops here, right? And then, okay, it gives you an error, but we'll solve that error in some time. Now, first of all, what is that error? See, we are trying to say that this is a price, but how will your enum will know that you're talking about a price here? Now, in this case, what we can do is, let's create a variable int price so that we can have an instance variable. And then if you observe here, don't you think this is a constructor? You can see it says that a constructor of laptop. That's right. We can have a constructor here. So when you create the object by passing a value, that's what we're doing here. We are saying these are the objects we have, and this is a constructor where we are passing a value. Okay, that means I can simply ask my editor, hey, I need a constructor here which takes the price. And yeah, we got a constructor. And now you can see there's no error. That means whatever value you're passing here will be assigned to this price. And the beauty is, this laptop is a class and all these are objects, and every object will have a different value for the price. It's not like once you define price for one object, it will be applicable for all. No, that's not the case. And once you have this, let's get back to our main. And here let me create a laptop lap is equal to, and let's say by default, maybe I want a MacBook here. And once you got the hold of MacBook, let's say I want to print. I want to print lap, which of course it will print MacBook. Let's try once. Yeah, it prints MacBook. I also want to print the price of it. Oh, now that's tricky because the price is private. And we have seen that. Make sure that your variables, the instance variables are private. How do we access this? Now, one way to do that is with the help of getters and setters. The only problem is, can we use them here? Yes, we can create our own methods. So what we can do here is I can right click and I will say, hey, I want getters and setters. Basically, you can change the value as well. Okay, so that means if I want to print the price, I can just come back here and I can print lap.getPrice. Now this is specifically for MacBook. So if I use a different object here, I will get a different price. And with that, if I try to compile and run, you can see we got 2000. Now what if you want to get all the laptops? Okay, let's try. So I will just comment these two sections. First of all, you need to get all the laptop. That means you need arrays. So it's the laptops. Or in fact, what you can do? You can directly use a loop here and you can say laptop lap colon from the laptop. So this is the enum. You want all the machines or all the constants. So how do we get all the values? So dot, we have seen this, right? We can use values here, which will give you the array, and one by one you can fetch the value. So what you can do is you can print the object, and also you can print the price. Let me print the price. How do I get the price? So it's a lap.getPrice. Okay, I hope this will work. Let me just verify once. Yeah, we can do that. So I'll say compile, run. You can see we got all the values. And at any point you can change the value as well. Okay, so you try that. So try to call setPrice and pass a particular value here and your price will change. Okay, there's one more thing. What if I don't specify the value for surface? Let's say we have a surface here and then I don't mention this value. Now what will happen? You can see we are getting an error. Why? Before it was working. The thing is, see, by default we have a default constructor, right? The moment you mention a parameterized constructor, it says, hey, if you want to get a constant, you need to set the price now because you have a parameterized constructor. There's no default constructor here. So you can say, okay, I know how to solve that. You can create a default constructor here. So you can just right click and say source action. Yes, I want a constructor without the price. Okay. And you can see we got a default constructor here and it's your choice if you want to specify some price here. So you can say price is equal to, let's say minimum $500. You can specify those things. And now if you can see the price for surface will be 500. Even if you don't mention, you will get a default constructor. And the beauty is you create 4 objects, it will call the constructor 4 times. This constructor 3 times and this one once. Let me just prove that point. I will just try to print something here. I will say in laptop. And let me also print the object name itself. I can just say this dot. So we got a name here. Let's try to see if this works. Compile and run. Okay, so that we got the name as well. So it says in laptop MacBook, in laptop XPS, in laptop ThinkPad, but not Surface. Is because Surface was created with the help of default constructor and we are not printing anything there. Okay, so that's how we use it. And mind you, we are using it as a private constructor, not a default or the public. It's because we are creating the object in the same class itself. And that's how the private constructor works. You can create the object in the same class. So yeah, that's it from this video where we talked about enum with a customized constructor, instance variable, and methods. In this video, let's talk about annotations. Now, annotation simply means a supplement to the compiler or to the runtime, or we also call it as a metadata. So basically what happens, when you write a code, sometimes you want to interact with a compiler by saying something. Of course, it will not change the way your code will work. It's just that we want to supply some extra information to the compiler or to the runtime. How do we do that? So let's say we will go for a normal class here. So let's say we have a class A and then we got a class B. So basically I'm trying to go for method overriding here. So of course we have to extend a class, and then this will have a method which is show, and then in this show I'm printing, let's say, in a show, and the same thing I can do in B as well. The only thing is we have to change it here. Now what we are doing here is we are overriding the show method of A with the show method of B, and then we have seen this before, right? Okay, let's create the object of B just to understand this. I will say B obj equal to new B, and then I can call obj.show, and we all know what will be the output. So if I compile this code and run, you can see it says in B show. Perfect. Now let's say I change this method name. Okay, not show but something else. I will say show the data which belongs to this class. Okay, so normally in Java we give a meaningful name to a method, right? And sometimes your method name can be big, and yes, okay, I know this is exaggerated, but sometimes you do have a big method names with 2 or 3 words or 4 words. And then of course, if you want to override this particular method, we have to type the same thing here. So I will say the data which belongs to this class. Okay, so again, I'm just trying to override the method of A class with the method of B class, right? And then of course we have to call this now. So I will just try to get it from the suggestion. Okay, so if you can see, I'm just trying to call this method, and what do you think? What will be the output? Of course, we have overridden the method, so it should call in B show, right? So if I compile this code and if I run this code, oh, it is printing in A show. Now we were expecting in B show. In fact, I wanted in B show, but we got in A show. Now this type of problems in programming is called bugs. Okay, bugs are simply logical problems where you are expecting something else and you got something else. Example, you want to say 2 plus 2 and the output is 4, but you got 5. That is logical problem. It's not a compile time issue, it's not a runtime issue, it's the logical. It's the logic which you have written is wrong. And one of the most difficult problem to solve is logical problems. We always say in programming that, you spend less time in coding and more time in debugging. That's what is happening here. So of course you have only 2 classes here and it is easy to debug. But if you have a lot of classes, it will be very difficult. Now how will you debug? Of course we are trying to call the method of B class, but we got the method of A class, right? How will you solve this problem? So let's try to understand the method name. On purpose, I changed the method names. Okay, I know it might be visible for a few people. You can see in belongs here, we have S. In this method, I don't have it. And sometimes you can miss it, right? And then when I'm calling it, I'm passing S. On purpose, I was calling the method of A class. This type of problems can arise when you write a code. So what you do is, you can show your intention to the compiler, and compiler will help you here. Of course, right, whenever you make a mistake, compiler gives you error. And looking at the error, we can easily understand, hey, I did something wrong and let's go back and solve this. So what if you can ask your compiler, hey compiler, you know what I'm doing here? I'm trying to override the method here of class A, and if it is not happening, let me know. So you can show your intention, and you can show the intention with the help of annotation. There are a lot of inbuilt annotations available in Java. One of them is override. So you can simply use @ here and you can say override. Now you are saying by doing this to your compiler, hey, I'm trying to override the method. And your compiler says, you know what? There's no method called show the data which belongs to this class in the A class. And then you will know, oh, I made a mistake. And then you can solve this problem just by putting S. Of course, you can compare these 2 methods and you can say, I got the problem. So of course, you have to solve the problem. So compiler is helping you by showing the problem, right? At least you got some help. And solving the problem at compile time is much better than solving the problem at runtime or when you deploy the application to the users. And then users will give you a prompt, hey, you made a mistake. So let's avoid that embarrassment and let's solve the problem at compile time. So @override is one of the way you can do that. And now if you try to compile and run, you will get in B show. Now, apart from this override, we have different annotations as well, which we normally use. In terms of core Java, we don't use most of the annotations. Of course, you can create your own annotations, but in general, we don't use much. Now, once you start working with the frameworks, example, when you talk about Hibernate framework or Spring framework, at that point, it is mostly driven by the annotations. Now, there are some annotations which works on the methods. There are some annotations which works on variables. There are some annotations which works on class level. So example, there might be some annotation which you will be using on class level. Example, if I say deprecated. Now, this is one of the annotation we have. Now, what we are saying that we have this class A. Deprecated simply means you can use it, but don't use it. It is deprecated. Soon it will be removed from the Java language, or there is a better alternative for this. So you can mark your class as deprecated so that if someone try to use your class, they will get to know that this class is deprecated. Now, apart from this, you can also use, okay, these are all class level annotations. In fact, we are going to see one more when we start with interfaces. Okay, so if I try to use something on the method level, let's see what we have. So we have save varargs for the variable arguments. We have suppress warning if you want to hide the warnings. Once we start with Hibernate framework, we'll also see transient. A functional interface we are going to see in the interface concept. Yeah. In fact, when you create your own annotations, we can also set the retention. So example, let's say whenever you use an annotation, till what level you want to set it. Do you want to set for compiler level? That simply means if you set a retention for compiler, it means once the code is compiled, the annotation will not make any sense after that. But if you say annotation is applicable for runtime as well, so after compiling as well, when the code is running, at that point also the annotation will be applicable. So we have different options there. And of course, this will make much more sense once we start working with frameworks. So we have different annotations. And remember when we were doing method overriding, and if you ask, example, let's say if I remove this part, and if I ask my IDE to generate a override method, so I can just go back here and say override, I want to override this particular method. By default, it will give you @override. Okay, so that's you have to remember. So yeah, that's it from this video where we talked about annotations. In this video, let's talk about different types of interfaces. So when you talk about different types, what are the options we have? So basically, we can divide the interfaces. So we'll say type of interface. We can divide interface into three parts. Okay. The first one can be, we can call them as normal interface. The second one is your functional interface. And the third one is your marker interface. Now this functional interface is also called as SAM. So why it is called SAM, we'll discuss in some time. But let's talk about interface here. Now when we talk about interface, at this point we know that in interface we can only declare methods, right? The thing is, after Java 8, we also got an option of defining the method in the interface, but we'll see that later. At this point, we only know that in the interface we can only declare methods. So all the methods in interface are public abstract, right? Now whenever you create the interface which has normal interface where you have multiple methods, it is called a normal interface. So example, if you create an interface here, and let's say the interface name is ABC, and in this interface, if you have two methods or more, that is normal interface. So whenever you have an interface with two or more methods, that's normal interface. And by doing this, you might have guessed it, right? What could be the functional interface? Now, basically, before talking about functional interface, let's talk about SAM. Now, SAM stands for Single Abstract Method. Okay, so that simply means if you have the interface, and let's say the interface name is ABC again, and in this interface, if you have only one method, that is called a Single Abstract Method Interface, which is SAM, and we can also call it as a functional interface. Now, why it is called functional, that we'll understand in the next video when we talk about functional interface. We have a separate video on that. And next one we have is a marker interface. Now, what is marker interface? A marker interface is an interface which has no methods. That's right, a blank interface. Now, why someone will create a blank interface is to update something to the compiler. So let's say if you want to talk to a compiler by saying, please allow this. Example, in Java, we have this concept of serialization, which means you can take the object and you can store the values of the object in your hard drive. Let me repeat. You can take the object, let's say object has multiple values, so we can create, let's say in your heap memory, okay, I will do that here. So let's say in your heap memory, you got an object and this object has different variables A, B, C, and this has some values. Let's say A value is 10, B value is 20, C value is 30. And then if you want to save this data in the hard drive, let's say we have a hard drive here, and if you want to store this data, we can use a concept of serialization. And then you can destroy this object. The thing is, why we are saving this object is because what if you want to recreate this object later? So let's say when you're playing a game and when you're playing this game, you want to save the game. Now, when you save the game, let's say when you're playing this game, the game takes around 4 GB or 5 GB in your RAM. But when you save the game, it will not consume that much of memory, right? It will consume around in KBs. It's because when you restart the game after closing it, of course, when you restart the game, you will get a default values. Now, if you want the old values, you want to resume the game, you will simply load the current stats. So let's say after some time you close the game, now game is no more, but you have a file in your hard drive and now you restarted the game. The value for A, B, C will be 0, 0, 0. What you can do is you can load these values from here. Now this is called deserialization. So this is serialization and this is deserialization. Okay. Now by default, every object is not allowed to do that. So it is not allowed. Okay. You have to give the permission. How will you give the permission? So you can simply create a class and you can give the permission with the help of marker interface. So we have a lot of marker interface in Java, serialization or serializable. Then when you talk about the advanced part also we have some interfaces, but it's important. Okay. So whenever you see an interface which is blank, that's a marker interface. And maybe in the upcoming videos, when you talk about some frameworks, we'll talk about different marker interfaces, but that's what it is. So what is normal interface, which has more than 2 methods or 2 or more than 2 methods? The functional interface or SAM only has 1 method. Now this is actually important for the upcoming videos and try to understand this. Every time you have an interface which has only 1 method, we can use some extra features with it. What are those features? We'll see that in the next video.